Hey everyone. So, if you've ever found yourself totally bogged down by slow, clunky nested loops, then I've got something for you. The sliding window technique. It's this incredibly elegant, high performance tool you've been looking for. It is an absolute game changer for anyone who codes. And today, we're going to unpack exactly how it works. All right, so here's our game plan. We're going to start with a really common problem, the kind that makes you think, there's got to be a better way. Then, we'll introduce the star of the show, this sliding window. We'll see how it works, check out its two main flavors, and then we'll see exactly why it's so powerful with a performance comparison. Sound good? Okay, let's dive in. Every great solution really starts with a problem. And in the world of programming, that problem is often the slow, brute force way of doing things that we all jump to first. Let's kick things off with a simple challenge. Imagine you've got a list of numbers. How would you find the biggest possible sum of any three numbers that are right next to each other? Just think about it for a second. How would you actually code that up? Well, the first thing that probably comes to mind is just checking every single possibility, right? You'd use one loop to pick a starting number, then another loop inside that to grab the next two, add them all up, and see if it's the biggest sum you've found so far. And yeah, that works, but boy, is it inefficient. So here's the kicker. That nested loop approach has what we call O of n squared, or big O of n squared time complexity. Now, all that really means is that as your list of numbers gets bigger, the time it takes to solve the problem just explodes. It's incredibly wasteful because you're constantly re-adding numbers you've already seen. There has to be a smarter way. And that smarter way, of course, is the sliding window technique. This is where we stop thinking brute force and start thinking smart. So what is it? At its heart, the sliding window is a clever pattern that takes those messy O of n problems and turns them into sleek, lightning-fast O of n solutions. It does this by creating a window, which is just a small piece of your data, and then intelligently sliding it across your list instead of starting over every single time. The performance boost is just massive. Here's a great way to think about it. Imagine you're on a train, looking out the window. As the train moves forward, new stuff, trees, houses, whatever, slides into your view on one side, while the old scenery disappears out the other side. You're not trying to process the entire landscape at once, right? You're just paying attention to the changes at the edges of your view. That's the beautiful, simple idea behind this technique. So how does the window actually slide? It might sound kind of magical, but the mechanics behind it are surprisingly simple. Instead of doing a full recalculation every time, we just do three little things with each slide. 1, we add the new element that's just entering the window on the right. 2, we subtract the old element that's falling off the back on the left. And 3, we update our result. That's it. This super simple, incremental update is the secret sauce to its amazing speed. Now, this technique isn't some one-size-fits-all magic bullet. It actually comes in two main flavors, and each one is perfect for a different kind of problem. On one hand, you've got the fixed-sized window. This is for problems exactly like the one we started with. Find the max sum of a subarray of a specific size, let's call it k. The window size never, ever changes. But on the other hand, you've got the variable size window. This one is more dynamic, it can grow and shrink. It's perfect for when you need to find, say, the smallest subarray that adds up to a certain number. The window expands until it meets the condition, then it shrinks from the other side. Okay, we've talked about how it works, but let's really get into why this matters so much. I'm not talking about a small improvement here. This is a total game changer for performance. Just look at this. The brute force method is O of n squared, while the sliding window is O of n. That's because with the sliding window, we only touch each element in our list twice. Once when it slides into the window, and once when it slides out. That's it. And that space complexity, O of k or O of n, just means we need a little bit of memory to keep track of what's inside our window at any given moment. Now this really puts it into perspective. For a list with just 1,000 items, the brute force way takes about 1,000,000 operations. The sliding window, about 2,000. That is an insane difference. It's the difference between an application that just hangs and freezes and one that feels totally instantaneous to your users. So where can you use this superpower? Well, all over the place. Think about a classic interview question like, find the longest substring without any repeating characters. That's a perfect job for a variable size window. You just expand the window to the right, adding new letters, and if you hit a duplicate, you shrink the window from the left until it's gone. It's the key to solving a huge class of problems efficiently. So let's bring it all together. The sliding window isn't just another algorithm for you to memorize. It's really a fundamental shift in how you can look at and solve a whole category of problems. Seriously, once you master this pattern, you're not just learning one solution. You're getting a key that unlocks optimal, efficient solutions for countless challenges you'll face with arrays and strings. It's an absolutely essential part of any modern programmer's toolkit. And that really brings us back to the core idea, doesn't it? Yes, it's incredibly fast, it's incredibly efficient, but its real beauty is that it just makes sense. It's an elegant, intuitive way to work with data, and that's what makes it so powerful. So I'll leave you with this final thought. Take a look at the code you're working on right now, the problems you're trying to solve. Are there any of those slow, inefficient, nested loops that could be totally transformed just by looking at the problem through a different kind of window? Thanks for tuning in.